Welcome to Tomorrow Unveiled, your weekly deep dive into the innovations shaping our future. This week, we are strapping in for a really fascinating journey. We're looking at the rapid evolution of wearable technology, and we're moving, it seems, beyond just simple gadgets to devices that are truly becoming an extension of ourselves.
It really is a profound shift.
Yeah.
We're calling it the strapped-in revolution.
Yeah.
Because it signifies, a fundamental leap. It's beyond just collecting data, like your daily step count.
Right, the fitness tracker model.
Exactly.
Yeah.
This is about seamless, symbiotic human-computer integration. The technology starts to blur the line between our own cognition and, well, computational power.
Yeah.
It's not just something you wear anymore.
It integrates with you.
Precisely.
That idea of blurring the line is really powerful. So what's actually driving this acceleration? Our dedicated research team, they've been diving deep into the latest trends, and they've identified 3 key forces that seem to be converging.
That's right. We're seeing these major advancements, first, in direct neural interfaces.
Yeah.
That's letting us communicate directly with machines using, well, our thoughts.
Mind-blowing stuff.
It really is. Then you have advanced haptic feedback systems, which let us sort of feel digital information.
Yeah.
And finally, the explosion of powerful on-device AI processing. That's the brains behind it all, really, letting these devices react instantly, in real time. And these aren't isolated breakthroughs. They're combining, they're weaving together to create something genuinely new.
Okay, so our mission today on Tomorrow Unveiled is to explore the most significant launches, the biggest research breakthroughs in wearable tech. Just from the past 7 days, that's August 24th to 30th, 2025. We've distilled it all from extensive research compiled by our team to give you a concise but hopefully comprehensive understanding of this incredibly dynamic field. So let's unpack this strapped-in paradigm shift a bit more. When we talk about moving beyond wearables, what does that practically mean? For how we'll interact with tech day to day.
It means we're shifting from, say, a passive interaction where tech just tracks us to an active one, almost an integrated partnership. The strapped-in idea isn't just about having a device on your wrist or your face. It's about that tech becoming an intuitive extension of your body, of your mind, helping you do more.
Okay.
Our analysis clearly shows this shift from sensors that just monitor passively to active, intuitive interaction. The tech genuinely enhances what we can do.
So it's not just about understanding ourselves better, maybe tracking sleep or steps, but actually augmenting our inherent capabilities.
Exactly.
Augmenting.
And you mentioned those 3 core pillars earlier, the neural interfaces, haptic feedback, and that crucial on-device AI.
Yeah.
How are these really converging to create this new reality, where wearables aren't just gadgets, but active enhancers?
Well, what's truly fascinating is their synergy. How they work together. Direct neural interfaces, they're opening up these pathways for us to control devices or maybe receive information straight from our brain signals, bypassing traditional inputs like buttons or screens.
No more typing on tiny keyboards, hopefully. And advanced haptics, they're building more realistic, more nuanced sensory experiences, allowing devices to communicate with us through touch in ways we're, frankly, only just beginning to explore.
Signaling data, almost.
In a sense, yes. And the crucial ingredient, the on-device AI processing, that's the engine. That makes all this real-time, intelligent interaction actually possible without needing that constant connection to the cloud. This convergence, this trio working together, that's the real game changer for enhancing human capabilities.
And it's not just theoretical, is it? We've seen some incredible product launches just this past week, things that are really shaping this near future. Let's start with AI-powered vision. The new Rocket glasses.
Yes, the Rocket glasses. They're a significant step towards that integrated future you mentioned. Launched this week, ultralight AI and AR smart glasses. They weigh just 49 grams.
49 grams. That's incredibly light.
It is, especially for what they pack inside. They're built on the Qualcomm AR1 platform, which is basically a powerful, compact chip designed specifically for these kinds of AR devices. They've got a 12-megapixel first-person camera and use micro-LED waveguide displays.
Okay, waveguides. That projects the image into your eye.
Exactly. It projects information directly into your field of view, like it's floating there. And the design is quite discreet. It even supports customizable prescription lenses.
So a really compact package. But what about its core functionality? You mentioned the AI. How does that on-device AI make it more than just a display? Positioning it as I think the term was cognitive co-pilot for the face.
Right, the cognitive co-pilot.
Yeah.
The on-device AI is the real differentiator here. These glasses offer real-time multi-language translation instantly.
Wow.
Yeah, and instant object recognition. So you can identify things just by looking at them, plus turn-by-turn navigation and even AI-powered problem-solving assistance.
So it's like having a smart assistant, but visual and hands-free.
Precisely. It moves far beyond just a simple display. It's designed to be this seamless, hands-free assistant that's always there, almost anticipating what you need. And the strategic insight here, according to our team's analysis, is how Rocket is positioning this. Not just a device, but your cognitive co-pilot, offloading mental tasks to this always-on, discrete AI. That really sets a new benchmark for accessible smart vision. And Rocket is also investing heavily in building an ecosystem around it. Partnerships with universities, a big developer community, that's critical for getting it adopted more widely.
Okay, that's a huge leap for augmenting our vision. But this whole strapped-in revolution isn't just about what we see, right? It's also about what we can do physically. Let's turn to physical augmentation. The Dinssey's Z1 knee exoskeleton. That sounds like a significant step.
It is. This is a major development in making powered physical support more accessible, moving beyond purely medical or heavy industrial use. The Dinssey Z1, it consists of 2 units, one for each leg. Each weighs about 1.5 pounds, and each has a pretty powerful 450-watt motor, so 900 watts total power across both legs.
1.5 pounds each, that's manageable. Is it rugged? Can you use it outdoors?
Seems so. It's built for real-world use, rated IP54 water resistant, so splashes, dust, that should be fine. And it includes a kinetic energy recovery system, KERS, like in Formula One.
KERS? Really?
Yeah, it harvests energy during movements like walking downhill to extend its 5-hour battery life.
Okay, clever. But how does it integrate so seamlessly? Is it just dumb mechanical assistance, or is there smart AI involved making it feel natural?
Oh, it's definitely the latter. The AI is key. What's truly revolutionary here is its predictive AI system. It runs on a dual-core processor in each unit, and it detects the initiation of movement in just 0.01 seconds.
0.01 seconds. That's incredibly fast.
It has to be, to feel natural. And over time, it learns your unique gait, your movement patterns. So it provides anticipatory support. It adapts to walking, running, cycling, even squatting across different terrains.
And the performance claims. Our research team flagged some pretty impressive numbers.
They are impressive. Boosting leg strength by potentially 50%, reducing knee pressure by a claimed 200%. And it can create the sensation of being 44 pounds lighter.
44 pounds lighter. Wow.
Yeah, or for high-impact sports, it can reportedly offload up to 330 pounds of knee load. The key insight here, really, is how this could democratize powered assistance, moving physical augmentation beyond those niche applications. It signals a future where maybe human physical limits become optional in some contexts.
Feeling 44 pounds lighter, it almost makes you wonder, like, will our morning hikes soon come with an optional power-up, like something out of a video game?
Maybe.
The performance claims are truly impressive, but does this level of physical augmentation raise new questions, like about competitive fairness in sports, or even how we define natural human ability?
It absolutely does, and those are big questions society will definitely need to grapple with. No easy answers there. But sticking with the tech for now, let's look at another take on AR glasses, the Reneo Air 3s Pro. It seems to focus on a different strategic approach compared to Rokit.
Yes, the Reneo Air 3s Pro. Our team noted this is all about perfecting the visual experience itself. It weighs a bit more, 74 grams, but it features a 1080p micro OLED display system with a very smooth 120 Hz refresh rate, and this is key, 1,200 nits of peak brightness.
That brightness is significant, nearly double its predecessor, apparently.
Yeah.
Makes it one of the brightest consumer AR displays out there. Really pushes the boundaries of visual fidelity in a wearable format.
So what's its primary function then, if it's not focused on integrated AI like Rokid?
It's positioned primarily as a high-fidelity portable virtual monitor. You connect it via a standard USB-C cable to your laptop, phone, whatever's compatible. And it turns into a private external monitor for productivity.
Or for entertainment, like a huge private screen.
Exactly. For immersive entertainment, you get a virtual 201-inch screen experience. Yeah. And this highlights what our research team called an emerging strategic split, or maybe a bifurcation, in the AR glasses market. You've got Rokid betting on integrated AI, the cognitive co-pilot, while Reneo is focusing on providing a superior display as a peripheral device, like a really high-quality personal screen.
Interesting. So are these glasses mainly intelligent assistants, or are they just advanced personal displays? The market seems to be exploring both paths.
That seems to be the question right now, yes.
Okay, moving beyond the commercial launches, the past week also saw some truly groundbreaking research, stuff that's really redefining the human-machine boundary. Let's delve into Stanford's incredible work on decoding inner monologue. That sounds like science fiction.
It does, doesn't it? But
Yeah.
it's becoming reality. This is a landmark study really pushed forward by the research team that compiled this information for us. They've demonstrated a brain-computer interface, a BCI, capable of decoding a user's silent inner speech directly from neural signals.
Directly from thought.
It uses microelectrode arrays, tiny sensors implanted in the brain's motor cortex. And then a sophisticated recurrent neural network that's an AI model particularly good at recognizing patterns in sequences, like language. It processes these signals.
Okay, implants and AI. What about accuracy? And maybe even more crucially, privacy. That sounds potentially risky.
Very valid concerns. The BCI achieved up to 74% accuracy in decoding imagined sentences. And that's from a massive 125,000-word vocabulary.
74% is quite high.
It is. But what's truly innovative and directly addresses that privacy concern is what they're calling the mind password feature. The system only starts decoding your inner thoughts after you mentally speak a preset phrase. The example used was chitty chitty bang bang.
Seriously, chitty chitty bang bang.
Ha, apparently so. And the system recognized that specific phrase with over 98% accuracy. So it creates this user-controlled gateway. It's privacy by design, built right in. The key insight here, our analysis suggests, is establishing user agency, giving individuals control over their own cognitive liberty. That's a critical precedent for neurotechnology going forward.
That mind password is a huge step for user control in BCI. That's reassuring. Now, in a parallel breakthrough, UC Davis revealed a speech neuroprosthesis. How does this compare to the Stanford work?
This is equally profound, but focused slightly differently. It's a BCI that translates brain signals from a patient with ALS, this Lou Gehrig's disease, into synthesized speech. In real time, it moves beyond previous BCI systems that mainly outputted text. This creates a much more natural conversational experience.
How does it work? Similar tech.
Similar principles, implanted microelectrodes again, but this one uses a different AI model, a multi-layered transformer-based AI, another powerful architecture for language. It decodes signals into acoustic speech features every 10 milliseconds, then instantly synthesizes an audible voice.
So it's not just about the words themselves, but actually the way they're spoken, the intonation, the rhythm.
Yeah. Exactly. That's the unique part. This system captures and reproduces prosodic elements of speech. You know, the natural rhythm, the intonation, the emphasis we use when we talk. For example, it captured the rising intonation for questions with 90.5% accuracy, and vocal emphasis with 95.7% accuracy.
That's incredible. That makes communication so much more human.
It really does. That ability to convey expressive nuance is vital for restoring truly natural, emotionally resonant conversation. It's a significant leap beyond just outputting the semantic content, the text. The key insight is how this tech is moving beyond mere function towards restoring truly human, expressive communication.
Amazing progress on the neural interface front. And rounding out the week's research, we saw some fascinating work from Tech on the future of touch and sensing, material science.
Yes, our research team flagged this one too. They've developed a novel tactile sensing platform using 3D printed smart materials. These are based on something called auxetic mechanical metamaterials, or AMMs.
Auxetic, what does that mean?
It means they have this counterintuitive property. When you compress them, they actually contract inward, perpendicular to the force. Most materials bulge outwards.
Huh, that is weird. Like pulling on them makes them fatter?
Sort of the reverse. Compressing makes them thinner width-wise. This inward contraction is the key.
Okay, strange property.
Hmm.
How does that enhance performance for wearables?
Well, this unique behavior concentrates the strain right in the sensing region. It dramatically enhances both sensitivity and stability for the sensor. Plus, you can precisely tune the sensor's performance just by altering the 3D printed geometry. No need to change the base material.
So, better tunable touch sensors? What are the implications?
Immense implications for future wearables. Think smart insoles that map pressure with incredible detail. Haptic gloves that let you feel virtual textures realistically. Next-generation prosthetics providing far more naturalistic sensory feedback. The key insight really is that by fundamentally rethinking material science, down at the structural level, we can unlock a whole new dimension of naturalistic sensory feedback for our devices.
Okay, let's zoom out a bit now. We've seen the devices, the research. How are these innovations already transforming industries? Let's start with healthcare and accessibility. That seems like a major area.
Absolutely. These innovations directly impact individuals in really profound ways. The BCI research we just discussed, for instance, offers real-time expressive communication for people with paralysis from conditions like ALS or stroke. That's life-changing.
Truly.
And AI-powered AR glasses like the Rocket model, could support dementia care, maybe facial recognition for loved ones, memory prompts displayed discreetly, and exoskeletons like the Dinssey Z1 could significantly aid mobility for a huge range of people.
Right.
The elderly, those recovering from injuries, even those advanced sensor materials from SealTech point towards smarter prosthetics, giving users more natural sensory feedback, connecting them more deeply to their world.
Huge potential there. What about beyond individual health, industrial, enterprise, defense applications?
Yeah, in those sectors, these technologies are really about boosting productivity and safety. Exoskeletons can reduce worker fatigue dramatically. Our research mentioned one example, allowing someone to comfortably carry 77 pounds for longer periods with much less strain.
That's a big difference for manual labor.
Huge. And for field technicians, imagine AR glasses providing hands-free access to schematics, data overlays right in their view, or enabling remote assistance, an expert guiding them visually through a complex repair from miles away. In defense, these systems enhance situational awareness. Critical data overlaid directly into a soldier's field of view. Better decisions, improved safety.
And for us consumers, productivity, entertainment.
Well, AR glasses are rapidly becoming these private portable virtual monitors. You can work on sensitive documents on a train, nobody else can see your screen, and they're becoming personal entertainment systems too. Gaming on a massive virtual screen, connecting to consoles like the Steam Deck. Looking ahead, those haptic advancements we talked about promise much more realistic, multi-sensory VR experiences, going way beyond today's simple controller buzzes, maybe feeling the texture of a virtual object, the recoil of a tool.
Feeling the texture. Wow. Now, what's really striking, and you touched on this, is how these applications often straddle this fascinating line. It seems the same underlying human-computer integration platforms are being used for both assistive purposes, restoring function, and augmentative purposes, enhancing normal function. Where do you see that line blurring the most, and what are the implications?
That's a critical observation, and it's something our team's analysis highlights frequently. That line is definitely dissolving. Look at BCIs. Initially developed to restore communication for those with paralysis, right? But they're also being explored for enhancing normal human function. Maybe faster thought to text or even thought to code for programmers.
Right, from therapy to enhancement.
Exactly. Same with exoskeletons. Rooted in medical rehab, but now marketed for performance enhancement for able-bodied hikers, athletes, workers. So you get this spectrum from therapy right through to enhancement, often using very similar core tech. And the implication is profound. It really challenges our definitions of human ability. It raises huge questions about equity. Who gets access to these enhancements? Does it create new divides? And it pushes us to reconsider what normal even means when technology can so seamlessly enhance or restore function.
Which brings us, very naturally, to the challenges and the considerations. Because with such deep integration, there have got to be significant hurdles, right? Let's start with privacy and security, especially with direct neural interfaces becoming a reality. That sounds like a minefield.
It is, potentially. The ability to directly access and interpret neural signals raises completely unprecedented privacy concerns. We're talking about neurodata, data that can reveal intimate thoughts, emotions. This goes way beyond traditional data privacy into areas like cognitive liberty, the fundamental freedom of your own thoughts.
Cognitive liberty, that's a powerful term.
It is. Imagine the implications if a device could infer your emotional state, or even fragments of your inner monologue without your explicit constant permission. And the cybersecurity threats are magnified too. A hacked BCI could potentially manipulate actions, maybe even induce neurological effects. It's scary stuff.
Yeah, that's terrifying.
And our research indicates significant inconsistencies right now in data governance among wearable manufacturers. Many explicitly state they share or even sell personal data. That's a major red flag when we're talking about brain data. Without really robust protections, this could easily open the door to highly invasive neuromarketing or even state surveillance.
That's a serious risk, yeah. What about the more practical side? Usability, adoption barriers for these new devices we've discussed. Are they comfortable? Easy to use?
Still some hurdles there. Even with lightweight designs like the Rocket glasses, physical discomfort, neck strain from wearing something on your head all day that remains a persistent issue for some users. Optical limitations are still common too. Narrow fields of view sometimes, maybe blurry edges on the virtual display, and often the need for custom prescription inserts, which adds hassle and cost.
And the social aspect. Wearing cameras on your face.
Right, the social friction. The conspicuous design of some devices can make people feel awkward. And bystander privacy concerns people getting nervous about integrated cameras recording them. That's a real barrier.
Yeah.
For exoskeletons, cost is still high, even for these prosumer models. And the added weight, while minimized, is still something users notice. But maybe the biggest hurdle for exoskeletons is the huge technical challenge of making that AI truly intuitive and safe. It has to adapt perfectly to the massive nuanced range of human movements. Any lag, any misstep by the AI, and that feeling of seamless integration is completely broken. Could even be dangerous.
And all of this seems to be happening in, well, a bit of a regulatory vacuum, doesn't it? Are laws keeping up?
Not really. That's a major concern our research team highlighted. Existing legal and ethical frameworks, things like HIPAAs for health data, GDPR for general data privacy, they're groundbreaking. But they weren't designed for this. They were built for things like health records, online browsing habits, not the direct output of our brains, our neural data. Our analysis points to this critical race between the tech capability and our socio-ethical readiness. Society's rules haven't caught up, and this vacuum creates a real potential for misuse, invasive neuromarketing, surveillance, if regulations don't adapt quickly. We urgently need new legal concepts, maybe something like neuro rights to protect our mental privacy and agency.
Neuro rights. Okay. As we wrap up this deep dive into the strapped-in revolution on Tomorrow Unveiled, let's pull together the key takeaways from this past week. What are the dominant trends we should really keep our eyes on?
Okay, 3 big ones stand out. First, the drive towards the naturalization of the interface. The whole industry is striving to create these intuitive interfaces, seamlessly aligned with how humans naturally interact, moving away from clunky buttons or awkward gestures towards thought or natural movement or gaze.
Making the tech disappear in a way.
Exactly. Second, Edge AI is undeniably the engine driving this integration. The increasing power of on-device, low-latency AI processing is what's making these new, intelligent, real-time interfaces actually feasible and responsive without relying constantly on the cloud.
Got it. And third?
Third, privacy by design is becoming absolutely critical. Features like Stanford Mind Password. As these technologies get more intimate, more integrated with our bodies and minds, user trust is paramount. And that trust has to be earned through transparent, user-controlled privacy features. That'll be a key differentiator for market acceptance.
Okay, natural interfaces, edge AI, and privacy by design. So what should we watch for specifically in the near term, say the next 6 to 12 months?
Our team anticipates seeing rapid integration of generative AI into eyewear, moving beyond just simple commands to fully conversational, context-aware AI assistants, ones that can maybe anticipate your needs.
Like a proactive Jarvis in your glasses.
Something like that. We also expect to see the commercialization of more multi-sensory haptics, bringing more complex feedback like pressure, texture, maybe even temperature into consumer devices. And definitely, those high-profile BCI studies we talked about this week. They're going to accelerate the public and legislative debate around neural rights, pushing for new laws to define and protect neural data as a fundamental human right.
That debate is definitely heating up. And looking further out, what's the long-term vision? Where does the strapped-in future ultimately lead?
Well, the convergent trends seem to point toward a future where the smartphone, as we know it today, gets disintermediated. It might not be the center of our digital lives anymore.
Replaced by what?
Computing could become distributed across a network of body-worn devices, maybe AR glasses for display, a smart wristband for input, eventually perhaps neural interfaces for really high bandwidth control and communication. It's this idea of pervasive computing, ambient, always available, and directly integrated with the user's body and senses. The physical phone might become less important, maybe even obsolete as the primary hub.
A truly integrated, body-centric computing experience. Which brings us to our final thought for you, our listeners. As we become increasingly strapped in, what new definition of human will emerge when our thoughts, senses, and even our strength are seamlessly intertwined with technology? Something to ponder. Thank you so much for joining us on this deep dive into the future here on Tomorrow Unveiled. If you're finding this insightful and you're watching on YouTube, please do take a moment to like this video, subscribe to Tomorrow Unveiled, and make sure you turn on notifications so you never miss an update on the future.
And if you're listening on a podcast service, maybe Apple Podcasts or Spotify, we'd be incredibly grateful if you could leave us a rating and review for Tomorrow Unveiled. It genuinely helps us reach new listeners interested in these topics.
Absolutely. And we love hearing your thoughts. Whether you're on YouTube or your favorite podcast app, leave a comment. Let us know what you think about wearable tech and this whole strapped-in revolution. We'll see you next time right here on Tomorrow Unveiled.